Ever wondered how our planet came into existence? How did Earth transform from a swirling cloud of dust into the beautiful blue world we live on today? In this video, we'll explore the origin of Earth, its internal structure, and the principles that help us understand its past. If you're a science enthusiast or a geology student, this is for you. So stay tuned and don't forget to hit subscribe for more geology insights. What is geology? Geology is the study of Earth, its surface, its oceans, and even its deep interior. It's not just about rocks, it's about understanding Earth's history and predicting its future. Here's a mind-blowing fact. Earth is about 4.6 billion years old, but humans? We've been around for only 2 million years. That's just 0.043% of Earth's history. The first multi-celled organisms appeared about 700 million years ago, so life itself has only witnessed about 15% of Earth's story. In truly understanding our planet, we need to look at processes happening today and interpret what happened in the past. Imagine this. A river deposits 1 millimeter of mud per year. After 100 years, just 10 centimeters, hardly noticeable. But over 10 million years, that's 10,000 meters, 6.2 miles of sediment. Earth changes slowly, but dramatically. Why study Earth? Why should we care about geology? First, we live on Earth, our survival depends on it. Second, all our resources, minerals, energy, come from Earth. Third, natural hazards like earthquakes, volcanic eruptions, and landslides can strike any time. And finally, curiosity. Understanding Earth helps us understand the universe. So how is Earth formed? Let's rewind to 13.6 billion years ago, the Big Bang. The universe expanded from a single point, forming light elements like hydrogen, helium, lithium, boron, and beryllium. Inside massive stars, nuclear fusion created heavier elements like carbon, silicon, calcium, magnesium, potassium, and iron. When these stars exploded as supernovae, even heavier elements, from iron to uranium, were born. Fast forward to 4.6 billion years ago, our solar system formed. Gas and dust swirled around the newborn sun, clumping into planetesimals. One of these grew into Earth. Gravity shaped it into a sphere. Then, a collision with a small planet created debris that formed our moon. Volcanic gases built the atmosphere, and when Earth cooled, water condensed, creating oceans. From cosmic dust to oceans and life. Incredible, isn't it? Earth's internal structure. Earth isn't uniform, it's layered like an onion. Each layer is unique in composition and properties. Let's go deep, literally. Chemically, we have crust, the outer layer, 10 to 70 kilometers thick for continents, and 2 to 10 kilometers for oceanic crust. Mantle extends to about 2,900 kilometers depth, made of peridot, solid but flows slowly due to heat. This is where convection drives plate tectonics. Core, outer core, 2,250 kilometers thick, liquid iron and nickel. Inner core, 1,230 kilometers radius, solid iron and nickel. Temperatures, up to 5,500 degrees Celsius, and pressures millions of times atmospheric pressure. Now, physically, Earth has lithosphere, rigid, about 100 kilometers thick, asthenosphere, soft, flows easily down to 350 kilometers, mesosphere, solid but can deform down to 2,900 kilometers, Outer core, liquid, from 2,900 kilometers to 5,150 kilometers. Inner core, solid, from 5,150 kilometers to Earth's center at 6,371 kilometers. From crust to core, Earth is a masterpiece of layers. How do we study the Earth? To understand Earth's past, we use the principle of uniformitarianism. The present is the key to the past. Processes we see today, erosion, volcanism, also happened millions of years ago. If we look at processes that occur today, we can infer that the same processes operated in the past. Rates can change, though. A river deposits slowly, but a storm can speed it up. Still, the laws of nature remain constant. So today, we learned how Earth formed, its internal structure, and the principles that guide geology. If you found this fascinating, give this video a thumbs up and subscribe for more geology content. Drop your questions in the comments. I'd love to hear from you. Until next time, keep exploring.